Good afternoon. Today we're gonna explain our result on air conditioning or AC system design for comfort inside a computer lab room in Central Jakarta. My name is Muhammad Fadil Maulana.
And my name is Muhammad Audi Hadika Kodri.
So the standards and calculation we use is the standard is from ASHRAE and SNI and Permendiknas, and we also use IES for recommended lighting levels.
Okay, now we go to the size of the rooms. So for the size of the room, the length would be 8 meters, the width would be 9.5 meters, and the height would be 3 meters. So according to the Permendiknas 24/2007, minimum room area for a computer lab is around 2 meters squared per student. And as you can see here, we can see the rest of the specification of the room. For instance, the glass thickness would be 0.006 meters. The wall thickness would be 0.195 meters. The surface area of the four lateral sides would be 105 meter per second, meter squared. The wall surface area is 102 meters squared. The room volume would be 228. The floor surface area would be 76 meters squared, and the glass surface area would be 3 meters squared.
For our application, we calculated the room area for per student is 3.8 meters square because we want a decent ventilation and airflow system on the room, and so the computer lab is not crowded, so the individuals can still move around and go to the peers computers without problems. For estimating the number of occupants and the activities taking place within the office, we use ASHRAE 62.1 2022. Said that the default occupant density for our computer room is 25 people per 100 meters squared. And for our application, which is 20 people, the estimated required area is 74.3 meters squared. To ensure occupant comfort and sufficient circulation space, we adjusted the room to 76 meters squared. And for the activity inside the space, we use the reference from ASHRAE 2005. We chose reading and seated because we assume that the students or individuals in the computer lab is going to be seated most of the time. And with the calculation of 20 people times 55 and 1.7, we get 1,870 watt. And for the 1.7 meter squared is we use body surface for normal adult, which is 1.7 meters squared.
All right, now continuing to the electronics and the lights. So for the electronics, we have four components. The first one is the CPU. We would need 20 units of that. That would result in 8,000 watts in total. And then we have monitor. We have 20 units of monitors. 400 that would result in 420 watts in total. And then we have projectors, 260 watts. Lights, 8 units, 288 watts in total. So according to the IES recommendation of lighting levels, the lighting levels that we would need for a room, for a computer room such as ours, is around 20 to 100 foot candles. So with the room that we designed, that is around 76 meters squared, or around 818 feet squared, the required illumination that we would need if we would use 30-foot candles is around 24,540 lumens.
For the CPU or computers that we are using, we actually reference it to the computer lab we have at campus. So the computer that the computer lab at campus is using is the Dell Precision T3600 with a power supply of 635 watts. And we assume that the students or the individuals would be using it with medium to high load. So we estimate the average power consumption to 400 watts. And for the lights that we use is the Philips Master, which have a maximum wattage per light of 36.
All right. Now we continue to the lights. So based on the SNI 6197 2020, the maximum light power density for a computer lab room such as ours is around 10.12 watt meter squared. So with a room that is a 76 meter squared, the maximum lighting that we would lighting power allowed for the room is around 769.12 watt. And also, we estimate the number of lamps that we require using our calculation. We would find that we would need that the value is 7.32, which if we would make the value whole, we would get 8 units per lamp.
For the insulation and the building materials, we use the SNI 6389 2020. And for the type of glass that are typically used in the computer lab room are the tinted single glaze type that has a U value of 5.5. And for the wall composition, we use an insulation with the R value of 2.5, the concrete with R value of 0.11, and the gypsum board with an R value of 0.06. And we get the total R value of 2.67. So we get the U value of 0.37.
So continuing to the outside air conditioning. So we again we would refer to SNI again. It's this time the 6390 2020 using table 1 and using the Jakarta Pusat as the project location. So at 2% annual frequency, the outdoor dry bulb temperature is around 33.3 degrees Celsius. That means the consumed wet bulb temperature is around 25.7 degrees Celsius, which represent the outdoor humidity. The humidification humidity ratio is 20.4 grams per kilogram, and that would show the moisture content in the outside air. Yeah, these values are important because fresh outdoor air entering the rooms adds both sensible heat from temperature and also latent heat from the humidity. We also note that the uh, peaky dry bulb and the peaky humidity are non-coincident, so meaning that they don't happen exactly the same time. So using both together gives a conservative estimate, which makes the cooling design safer and ensure the HVAC system can handle worst case conditions.
Okay, for the indoor air, we base on SNI 036572 2001 with the procedures for designing ventilation and air conditioning system in building structures. We learned that the optimal comfort is around 22.8 Celsius to 25.8 Celsius. And for the tropical region, the relative humidity that are recommended are 40% to 50%. But for a packed meeting room, is around 55% to 60%.
All right. Now we continue to the indoor condition. So again, we would base it on the ASHRAE 62.1 2020. We would have the values of the minimum ventilation rates in the breathing zone for a computer room. And we would find the values below that relates to the computer lab. So ventilation rate per person is 10 CFM per person. The ventilation rate per room area is 0.12 CFM feet squared. The total ventilation rate would be 298.167 CFM.
This is the calculation table that we use for the computer room cooling load or capacity. The total room heat load is 18,000 watts. So for the cooling capacity that we need a minimum cooling capacity of 18,000 watt to 27,000 watts with a safety factor of 1.5. This is the air cooling unit that we find. We chose this because in the Panasonic product line, this is the most suitable with a cooling capacity of 10 kilowatts. Because we need around 18 to 27 kilowatt, we use 2 units, and the power consumption is 3.23 kilowatts, and the coefficient of performance is 3.10, and the air volume is 1,285 CFM.
So continuing to the estimated initial and operational cost for the cooling system. So for the AC installation and maintenance cost breakdown, the price per unit, we need 2 units, would be 75,710,000 rupiah. And monthly power consumption would be around 1,317,475,000 rupiah. And also the delivery price would be 200,000 rupiah. The unit install price would be 500,000 rupiah. The routine check per 3 months would be 350,000 rupiah. So the CIPEX would be 76,410,000 rupiah. And also the yearly operational expenditure or OPEX would be around 15,809,000 rupiah per year.
The delivery price, unit install price, and routine check per 3 months is an estimate based on our analysis and based on the price several services offer. And for the routine check per 3 months, we have 350,000 is from the routine check. 350,000 rupiah price we get is from a typical AC unit cleaning services. So the three of this price would fluctuate based on the services that are used. For
All right,
the
so
energy saving recommendations, we recommend a simple but effective solution. We can reduce incoming heat from windows by using thermal blinds. This would physically black out or thermal blinds during peak daylight hours to prevent radiant heat from warming the inside of the lab. And we propose regular maintenance of the computers because dust buildup in the heat sinks or cooling system of the computer can increase the wattage usage for the computer and increase the heat of the overall computer.
all right, so for the conclusion, the thermal comfort in the computer room was determined using heat load calculation based on ASHRAE and SNI standards. The main heat sources are ventilation, occupants, electronic equipments, lighting, and heat transfer through walls and glass. And then from the calculation, the total cooling load is around 18,150 watts, which is the minimum needed for indoor comfort. And then with a 1.5 safety factor, the recommended AC capacity is 18,000 to 27,000 watts. Therefore, the selected air conditioning system must meet this cooling range to keep the room comfortable and equipment reliable. So for better efficiency, we would need to use energy saving lighting, controlled ventilation, and good insulation to reduce cooling demands.
That is it for our presentation. Thank you.
Thank you.